Okay, it's 5 after. I think we'll get started now. I'm sure we'll have other people trickle in, but we'll catch up. So, thank you and welcome to Cloud Native Madison December meetup. Again, please mute. I'm sure we'll leave some time at the end to ask questions and come off mute. Else, there is the Q&A or just the chat within the Bevy platform that you can utilize. Sponsor, well, not really, because Branden is from Zendesk, so give them the sponsorship here. So thank you for the time to put that together and everything and sponsor us. News and notes for this month. reInvent still going on this week. I think you can still sign up and watch the keynotes. I don't believe there's any sort of charge for that at this point in time. I'm not sure what the live attendance was out this year, but obviously that's probably one of the biggest events, sort of more general events of the year. So a lot of good stuff coming out of that. And speaking of information coming out of that, AWS did launch Carpenter, and that's a autoscaler for Kubernetes clusters, and it is meant to be, cluster agnostic. So it's not specific to AWS's EKS cluster. It can be used on any cluster. It's interesting, and I still haven't, they go into a lot of the details of why the current autoscalers that are built in already don't quite work. They go into a little more right sizing the nodes that they're standing up along with that. So be interesting to see if this catches on, but it definitely could help some organizations save some money, it looks like, as well. So interesting there. Another thing that caught my attention this month was an interesting name for a cloud company, Mainframe Industries. They raised 22 million. I believe it was their B round of money here again, but they're doing cloud native games, and not necessarily specific to the cloud native technologies that we often talk about, but they're more looking for just games that execute natively in the cloud in building those. So it's interesting to see the gaming industry, come into this space a little and see what's going to happen there. Obviously, Google had their streaming gaming service, but I think that was a little more around, streaming of traditional games, where this seems like they're trying to hit a little different approach with these cloud native games, what they're doing here. So interesting and curious to see what's going to happen with that long term as well. We still have this community call out for a presentation on Crossplane, which we hope to do on February, because we will be skipping January for a meetup as we always do. So yeah, if you're interested in Crossplane, and Crossplane is a way to configure cloud infrastructure, through the Kubernetes API. And hopefully someone can do that and just get some sort of intro. It has to be very 101 type thing. You don't have to know anything about it coming in, but see if you can give a talk on that. So if you're interested in that, please let either myself, Branden, or Steve know you're coming up. So as I said, our next meetup will be February 3rd, 2022 already. It seems like we got there pretty quick this year. Maybe that's just me. So that will be February 3rd, New Central. Again, not knowing the speaker, hopefully somebody here on there will be want to give a presentation of that, but hopefully it will be that Crossplane presentation there on February 3rd. The other important thing to note about that is the integration that the CNCF gives us, as far as the Bevy platform, the community groups. They had an integration with Meetup that they sponsored throughout the end of this year, and they're going to discontinue that. So we're not sure. Branden and I talked about it just a little before this. I'm thinking we may, do that dual announcement anyways. We'll just keep going there. There may not be that nice integration, so a little extra work on ours to do that. If you have some opinions on that, whether you like to see things on Meetup or it really doesn't matter to you, let us know one way or another. You can throw that in the chat right now if you want as well. if you have an opinion on that. But it may or may not be announced on Meetup, so just know that. But it certainly will be announced on the community site here, through the Bevy platform. With that is going to be Branden. Branden is obviously a co-organizer here of Cloud Native Madison. He's a senior staff engineer at Zendesk, and he's going to talk to us about solving the cloud native complexity with Porter. So with that, Branden, I'll turn it over to you.
All right. Thank you, Kurt. Start sharing my desktop here. All right. Everybody see that presentation okay?
Looks good here.
All right, great. Well, thank you, Kurt. As Kurt mentioned, my name is Branden Timm, and yeah, I'm an engineer at Zendesk in the engineering productivity group there. So, our main charge is to try to really streamline and make as efficient as possible our developers' experience writing code for our customers at Zendesk. So just start real quick and talk about sort of what the motivation is for this talk here. So, cloud native continues to grow and grow and grow. Which what you're seeing here is the CNCF landscape, which you can go and take a look at on their website. And, it's just really impressive to see the number of projects that have kind of come into the ecosystem and the number of companies and kind of, all the other things in the orbit of CNCF. But one thing that's continuously on my mind, at least, particularly working in a discipline like engineering productivity, is that it feels like while the technology has sprawled and we have all these amazing capabilities, that more and more I kind of wish that there was more of sort of a common way to sort of piece these things together through common, infrastructure or a configuration plane. If you think about gluing these things together and dealing with parameterizing them and how you get credentials in and out of them, it feels like a place that we haven't really solved for yet. So one of my favorite podcasts is the Go Time podcast. Those of you that know me probably know that my preferred language these days is Go. Definitely recommend checking out their podcast, even if you're not a Go developer. They cover a lot of topics around sort of the meta aspects of being a software engineer and cloud native technologies, which of course are largely implemented in Go these days. But came across an episode called All About Porter. And this podcast episode featured Carolyn Van Slick, who's a principal engineer at Microsoft, talking about, kind of this very problem of, we have all these technologies, but, sometimes it's hard to piece them together. And so, maybe if you're at a company that has, teams dedicated to cloud infrastructure and teams dedicated to, providing a nice configuration plane to piece those things together and get your parameters in there, get your credentials in there, maybe this is somewhat of a solved problem for you at great engineering expense. But for things like small development environments, proof of concepts, or especially if you have some cloud native software that has dependencies on cloud infrastructure and other systems that you want to be able to give to somebody to easily kind of stand up and kick the tires on, that's still really kind of an unsolved problem. And that's kind of where Porter is trying to fit in here. So really the question here is like, where's the glue for all these different things, right? You might have some Helm templates to actually, define how you apply your application out to Kubernetes. You may rely on something like HashiCorp Vault to get your secrets in there. You probably have some JSON or YAML and other places, maybe doing some definitions, maybe use Terraform to stand up some cloud infrastructure. And maybe to glue that all together, you just have some bash scripts that are kind of stuck into a repo somewhere, and somebody has to kind of go, and hopefully you've documented that well. If not, gonna go read that bash script and kind of figure out how all that stuff gets provisioned together there. And so, wouldn't it be nice if we had a system where we could put all of the tools that we need to deploy an application into a single image? And in this case, we're going to talk about Docker images, but you can imagine it's even other things maybe. It's kind of an implementation detail. But if you had all those tools kind of bundled together, and then you had a way to define a schema that said all of the parameters and credentials needed to actually get those tools to stand up your application, and then you had some sort of tool that allowed you to actually execute that install recipe or that upgrade recipe or that uninstall recipe, then we could probably really, really drastically lower the friction to doing these kind of, quick, development environments, proof of concepts, or distributing something for other people to play with, and give them a more standard interface by which they deal with all these things instead of having to go and read your bespoke scripts sitting in a Git repo somewhere to figure out how to stand it all up. So that essentially is what Porter is. But before we can talk about Porter itself, we actually need to talk about something a little bit lower level, and that is Cloud Native Application Bundles, or CNABs. Probably just going to refer to these as bundles for the rest of this presentation and make it easier on myself. But let's take a quick look at what a CNAB is. So CNAB is actually a spec to describe how to securely kind of bundle things together, your application, everything needed to actually deploy it out there and manage that application and its dependencies. It was co-developed by the companies you see on the right side here, so Microsoft, HashiCorp, et cetera, who all kind of coalesced around this space and said, like, there's clearly kind of a problem to solve here, and maybe we can come up with an open spec to define how these things should work, and then we can build implementations on top of that spec. So the main core kind of entity in the spec is this idea of a bundle. And a bundle is really just three things. The first is your application image. And again, technically that could be something like an AMI or a virtual machine image. It could be a Docker image. But generally speaking, it's going to be however you're bundling up your application into some sort of like deployable unit, just like you are today. And by and large, not by and large, it definitely doesn't not require any changes to your existing application image in order to work in this bundle. So if you're already containerizing your application today, you can bring that to the bundle with no changes. The second piece is an invocation image, and you can really think about this as kind of the installer. So that's the image where all of your tools are going to get installed to. That is essentially going to be executed then by some runtime tool that implements the CNAB spec in order to actually deploy out your application. And then the third piece is just a bundle descriptor. And so this is a file that kind of like glues the knowledge about your invocation image and your application and all the other things together to kind of define that bundle. So a little bit more about invocation images. As I said, it's meant to contain all of the tools needed. So you can imagine you need Packer or Terraform or Helm. The CNAB spec defines how you would bundle all those into one or more invocation images. And that invocation image then also has an entry point script that understands some well-known verbs like install, upgrade, or uninstall, and then actually goes about the business of installing your application using the tools that have been bundled into that image. And then you have the bundle descriptor. So according to the spec, the bundle descriptor is a machine readable, JSON file with a schema behind it that defines all of this for your application. So your application images, which by the way, you don't even need to have an application image in the bundle. You could just have an invocation image as well as the bundle if let's say your installers just need to go out and grab other resources to do your install. This would define what credentials are necessary to actually work with the bundle, inputs and outputs and parameters, and then metadata such as the version, the author, the description of the bundle itself, etc. So the bundle lifecycle, once you have it built, looks something like this, right? The author builds that bundle somehow using some tooling that implements the CNAB bundle spec. You publish that bundle to an OCI compliant registry. And so this is one of the really cool things about the spec is, for those who may not be familiar, OCI is really kind of the open spec that grew out of the Docker spec for a registry and how it contains those images. But there's really nothing special about that OCI compliant registry in terms of it having to be just Docker images or image layers. It actually can store any sort of content addressable, blob. And so, you can send both your invocation layers and your application layers, as well as that actual bundle JSON file, up into an OCI compliant registry, and it can kind of treat those all as one bundle. And the nice thing then is you can use Docker Hub or Amazon's registry, GitHub's registry, et cetera, et cetera. Any OCI compliant registry can be used to publish to, and then for people to grab those images out of. So then on the consumer side, again, you have some tool that implements a CNAB spec. It reaches out to that OCI compliant registry, pulls that down, and then gives you a consistent interface by which you can actually execute that installation. So that brings us then to Porter. And as we all know, specs are really great for kind of sketching out how things should work and making sure that things can be interoperable and validated when you're actually going about the implementation. But just having a bundle JSON, an invocation image, and a application image is not really enough to get useful and productive with it for actual end users. And so Porter is taking that spec and really trying to build some convenience things on top of it, and some ways that you can actually interact with these things on a little bit higher level. So Porter itself, as I said, is an opinionated implementation of the CNAB spec, and it allows you to author, distribute, and execute these CNAB bundles. And as it says there, I think their mascot is pretty snazzy too. So at a high level, we can talk about the Porter components here. So the first one to call out is the Porter CLI itself. So that's a command line utility that you can get for any common platform that allows you to scaffold up new projects. You can create parameter and credential sets for a given bundle. You can use it to build and publish, actually push to that OCI compliant registry your bundle. You can also use it to actually execute those bundle actions. So install, upgrade, uninstall. And there's a couple of other things it does as well, like linting your bundles and things like that. So that's kind of your all-in-one Swiss Army knife for working with Porter. The second major component of a Porter bundle is their YAML file. So, the original spec defines JSON as the definition for an actual bundle, but their YAML is kind of like a more human-friendly translation layer to go between, the YAML and actually get a fully, manifested bundle spec written out there for you. So this is again going to define your bundle metadata, your required parameters and credentials, the actual steps of your actions, and the bundle outputs. So you can imagine if you have a bundle that's going to go install something, and maybe when it's all done, you want to return a URL to the system it deployed, you can go ahead and use it for that as well. The next major concept that Porter brings in to help with authoring bundles is this concept of mixins. And so, you can imagine with a Docker invocation image, you could go ahead and, build out the Docker file for all that and add your tools in. But, maybe for well-known tools that people are going to commonly use like Helm or Google Cloud or Azure or Kubernetes, Terraform, they wanted to essentially package up some pre-existing functionality that does a couple of things for you to get you further down the road when you start. So the first thing is you can just include a mixin to your Porter bundle, and it will automatically handle the installation of that to your invocation image. The second thing it does is it defines a JSON schema that defines like the configuration of how you want to run that tool, as well as any inputs, outputs, and behavior you need. And so that JSON schema is ultimately used to validate your execution of that mixin that you write in your porter.yaml file. And then the mixin architecture is really pretty simple and open. These are not actually in the process space of the Porter CLI; they're outside. The Porter CLI actually communicates with these mixins just over standard in and standard out. And so authoring one of these can be done in essentially any language because essentially it just expects some input from the Porter CLI, it does its thing, and then it passes input back over the standard out to the Porter CLI itself. And then there's also plugins. So plugins for Porter are a little bit deeper integration, probably a little bit more effort to write. These would be actually in the process space of the Porter CLI itself. And so you'd be writing these in Go. But these give you ways to override or re-implement behavior that's going on within the Porter CLI itself. So the two main types of plugins there are for it are for storage. So if you want to go out to a different system and store things like parameters or credentials, you can do that. And the other one is for secrets, for actually storing your secrets out there. So, for example, you can store parameter sets in Azure or Kubernetes. You can store secrets up to Kubernetes secret manifests, or you can pull secrets from HashiCorp Vault. So yeah, and we'll see a couple more, I'm sure, in the horizon here as well. So that was kind of the quick high level overview of what a bundle is and kind of what Porter does. So I thought it would be cool to try to actually implement a pretty simple bundle to actually see what this looks like if you were to go about doing it. And so I looked around my group at Zendesk looking for what would be a simple use case to try to implement a bundle for, where we could actually save some save some effort. And so, one of the things that our teams at Zendesk work with is Spinnaker. That's our deployment platform we use for everything. And in order to like actually kind of develop against Spinnaker, it's not the most straightforward because it's a pretty heavy application. It's something like 12 different services with multiple replicas running. It has several different data stores, and so it's too heavy to actually just run on your laptop and kind of hack against. And so one of the ways we've addressed this in the past is we have this project out here called My Little Spinnaker, and what it does is it deploys out a pretty hefty, like I think an M4X large EC2 instance. It actually deploys K3s, which is a lightweight Kubernetes distribution, to that EC2 node. And then it runs Spinnaker's configuration system Halyard to actually bring Spinnaker up on that node. And in theory, if all goes right, at the end of this, you kind of get, here's your Spinnaker URL, go nuts. But you can, even this, is probably pretty reasonable, and people have seen little examples like this before. But even this, you can understand that like you really have to probably work a little bit too hard to make this work. So, for example, logging into one of the Zendesk sandbox accounts and connecting to Zendesk VPN. Well, what if an engineer hasn't actually ever logged in? What if they don't know how to log into the sandbox account and get their local credential working correctly and things like that? Installing Terraform and Packer. It's like, okay, what versions? Is that important? Am I going to blow up here if I have too new or too old of a version of those tools? And then, going and reading a bash script to understand options that need to be passed in. And, I've done, I'm sure like many of us, my fair share of bash over the years, but it feels like we should have moved beyond the point of saying, go read this bash script to figure out how this works at this point. So it'd be great if we just had a standard interface to understand what the inputs were and sort of how they're going to be validated. So let's go ahead and take a look. Oops. Actually, I'm going to jump out here now, and we're going to go ahead and try to see if we can get a bundle that does all those steps for us with a little bit nicer interface on it. So I'm in my code directory here, and I'm going to make a new directory for spin demo. And the first thing I'm going to do is I'm going to go ahead and scaffold out my bundle. And so for this, we say porter bundles create. Okay. So we can see that went ahead and created several things within the directory here. So we have a Docker file, a README, a bash script for helpers, and our porter.yaml file. So I'm actually going to go ahead and open that up in my IDE here. Moment. Close a couple windows here. Okay, great. So yeah, so you can see we have a README here. We have a Docker ignore, a git ignore, a helper's bash file. We'll see what that does in a second, and our porter.yaml file. So this is a good place to start. And let me know if this isn't big enough for folks. Excuse me. So the first thing we see at the top here is we have some metadata. So let's go ahead and rewrite this. We're going to say this is spin demo version 010 is fine. So we're going to say an installer for Spinnaker on K3s using EC2. And the registry here refers to, what is the base of an OCI registry we want to actually upload to. So by default, this would be, I think, Docker Hub / Git Porter. I'm not sure I'm actually going to publish this today, but I'm going to replace that with my Docker Hub name. So if I did want to push this, it would go ahead and go there. And let's take a look at the rest of this kind of scaffolded out file here. So the first thing we see here is Mixins. And so by default with the scaffold, we only have one mixin in play here, and that is exec. And so exec is, as you might imagine, essentially just like a shell sort of mixin. It's actually going to be able to go ahead and go out and run scripts for us. And it has its own schema for, under each one of these install, upgrade, or uninstall actions, it can take those options. And so right now you can see this is really simple. We have install hello world calling helpers.sh install. So if we look at that, again, I'll blow this up a little bit, but install is just going to echo hello world. Upgrade and uninstall are going to do similar things, world 2.0 and goodbye world. So that's pretty simple. You can see we have a commented out section here for tracking credentials as well as parameters. We'll get to those in a little bit here. But even with this right here, what we can do is fire up a terminal, and in my directory here, I can say porter explain. And the first thing I want you to note is that I've never actually built this bundle and I'm trying to explain it. And so Porter is smart enough to understand either that this doesn't exist yet or something has changed in part of this bundle. And so even if you don't explicitly call Porter build, it's going to notice that and will run a build and then give you the output of any commands you have there. So everything that would normally be so essentially this is all the results of the build here. So if I just execute this again, I'll just get the actual metadata. So you can see that's all coming in there, and I don't have anything else defined here at the moment. So this is a good place to go ahead and get started. So let's actually bounce over to the actual project that I'm trying to re-implement as part of this bundle, and take a look at the script that kind of goes ahead and provisions things. So first thing you'll notice here is at the top of the bash script, we have a usage, block here that defines sort of all the parameters that need to be fed into this script. We're then checking for essentially short options to be passed in for all those. Again, getting the options and passing them into their arguments. Making sure all those arguments have actually been set, and then we can finally actually kind of get down to the business logic of deploying this Spinnaker setup. So the first thing it does is it just validates that your Amazon STS credential is indeed valid before it moves on. It then makes sure that there's actually a default VPC to deploy to in the account that you're trying to deploy this to. If not, it'll go ahead and create it, and then it's going to use Terraform here to actually go ahead and stand up the EC2 instance, security groups, everything else needed, an elastic IP, et cetera, that you would typically need to install this. And before it can do that, it needs to essentially take this terraform.tf file and essentially do a replace of all the arguments you passed in to that TF vars. Once that's done, it does a Terraform init and then actually does a Terraform apply, and then checks whether or not that was successful. If not, it'll go ahead and destroy that. So the way this is going to kind of fall out is we essentially have two different kind of like steps here, right? We kind of have the AWS steps and then we have our Terraform steps. Now, there is an AWS mixin available within Porter. However, I thought for demonstration purposes, it might be a little bit easier or more interesting, I should say, to actually use the exec mixin to do the AWS pieces here. Because with the exec mixin, you're a little bit more on your own to install the needed tools that would be called in your exec scripts. So we're going to start there, and that's also going to take a minute to install the AWS CLI and things like that. So we'll get a little bit ahead, so you don't have to sit here and watch a Docker image build. So the first thing I'm going to do here is uncomment this Docker file line. So if you're only ever using the built-in mixins and you don't need to bring any other tooling to the table, you can leave this commented out. But the purpose of this is if you do need to inject more tools into that invocation images, you can uncomment this, come into here, and add what you need here. So one thing to note here is one expectation is that these Docker images are built off of Debian-based tooling. That's just because all of the mixins and things like that actually get their installation get tacked into this Docker file, and they expect to use apt-get. So, but you can use any Debian-based distribution as your base image here. So the first thing I'm going to do here is I'm going to pull in my installation of AWS CLI because we're going to need that for our exec mixin. So this just looks like that. So we're just installing Python and Python pip. Then we're going to go ahead and run or install AWS CLI. So I'm going to go ahead and say Porter build. And while that is running in the background, then we're going to come back to this script here. And so once we have that AWS CLI, we're going to need some parameters to start passing in here. So again, going up to the top, you can see we have owner, identifier, region, team, and SSH key. So if we come into our Porter file here, we find this parameters section. And one of the really nice things about the parameters section is it doesn't just allow you to define your parameters, you can also define validation on your parameters itself. So if we kind of bring these up side by side and say, okay, well, we're going to need an owner, and that owner is going to be an email. And so we're not going to default that, but another nice thing we can do here is we can actually put in a regex here to validate the parameter is some email address ending in zendesk.com. So we can do this. The next thing we need is an identifier. That's also going to be a string. And that is just going to be a unique name for this deployment. So we'll go ahead and put that description on there as well. Um, I forgot, we're actually going to put a description on our owner parameter as well. Then we need the region. And again, we're going to use some validation here to help us out. So that's a string, but I only want to allow people to select 2 different regions that they can actually deploy to here. So for that, we can actually use an enumeration validation of US East 2 or US West 1. And then we're also going to need the team. So this is just used for the tags that we're going to apply to these AWS instances for billing and tracking and things like that. Okay, and I think that's all we're going to need at the moment. And in fact, let's go ahead and take a look at what that looks like already. So now with those parameters in there, you can see if we do porter explain. Oops, mapping value is not allowed in this context. So I think I have some indentation issue here. Let's back that up. That should be good. There we go. So you can see again this change. So it's actually automatically building my image. It did already build and has the cache layer from my installation of the AWS CLI. So that doesn't need to be done over again. Excuse me. So yeah, you can already see that now I have these parameters out here with a nice description of each, what type they are, and what actions they apply to, along with whether or not they're required. So that's kind of your user interface off to that. So now that we have that, we can start taking a look at what the script is going to want to do for the actual AWS authentication piece here. And in fact, we're going to write one script that takes care of both of these, checking our AWS credentials and then essentially creating a default VPC if that doesn't exist. So I'm just going to create a scripts directory, and I'm going to create a script called create VPC sh, and I'm going to mark that executable right away so don't forget that. Okay. And then I have a slightly modified version of the script you saw in the source project that we're kind of working off of here, but I'll bring this in and kind of step through it and show what's happening here. So it's just a bash script. We expect 2 parameters to be passed in. The profile, which is the actual name of the AWS profile I wanted to leverage, and then the region itself. And then just like in the source script, we're just calling AWS STS get caller identity, and then bailing out if I don't get a 0 exit code from that. And then we're going to run the EC2 steps to describe whether there is a default VPC and then go ahead and create that. Before I do that, I do need one other parameter here, and that is my profile. So profile is actually, again, just a string that indicates the name of the AWS profile I want to use. So I'm going to go ahead and pull that in here. And then I'm also now going to need some credentials, right? I actually need a way to pass my STS credential into this running image. And so I'm going to pull in here my STS credential map. 1 second. So I'm going to call this AWS STS creds. And I'm going to tell Porter that I want it to write that credential to /root.aws/credentials. So now again, if we do a porter explain, it's going to rebuild my image. And now in addition to my parameters, I should also see that credential being listed out there. And credentials AWS TS creds with a nice description of exactly what it is I want there. Okay, cool. So with that now, we're kind of ready to build our initial calling of that script and how we want to actually map parameters and credentials into that step. So this first one is actually going to be, instead of install hello world, it's going to be create default VPC. The command instead of helpers is going to be scripts create vpc.sh. And then for my arguments here, what I can do is I can actually use interpolation within here based on the parameters and the credentials to pass those in nicely to this step. So this is going to look like this. I'll back that up a little bit. Excuse me. So you can see we're actually just referencing using dot notation bundle.parameters.aws profile and bundle.parameters.region. That, I'm sure you won't be surprised, maps to AWS profile and region here. And so they're going to be passed in that order. And so just as a reminder, in the scripts, I'm expecting profile first, region second, and then mapping those variables in so I can use them down here. Okay. So we're at a point now where we can actually test out running this command, but we need to do a couple of things first. The first thing we have to do is I'm actually just going to authenticate with our sandbox environment so that I actually have a valid STS credential that can be passed through. And hope that Duo doesn't take too long here. Okay, great. So that's there. So now, in order to use credentials, we create what's called a credential set. And so if I pull this up a little bit here, where the command is porter credentials generate. And again, it's going to rebuild my image real quick, but then it's going to interrogate this porter.yaml, see what kind of credentials are needed, and then give me an interactive way to pass those in. So it's saying, how would I like to set this credential AWS STS creds? So I'm actually going to use a file path, and I'm going to point it at home.aws/credentials. Okay. Now I can also create parameter sets if I want to create something that's saved that defines all these things out here. But for the purposes of this demo, I think I'm just going to do it all out on the command line to make it a bit easier. So at this point, I'm going to say porter install. Second, go to my history here. Porter install. There we go. Okay, so the cred name in this case should be spin demo because it'll just follow the name of the bundle itself. And then I'm going to set some parameters here. Actually, I'm not going to use a parameter set, but I'm going to use just the command line to set some of these. So I'm going to say an identifier is spin7, param owner equals sandbox.com, region equals US East 2. And then I just need team and profile. Param team equals engineering productivity. Param profile equals sandbox. What did I log into there? Sandbox 1? Yeah, sandbox 1. Okay. And I'm also going to pass in debug on this so we can kind of see what's happening here. Parameter profile not defined in bundle. Let's see. Oh, AWS profile. Oh, and so there we go. Nice example of our validation. So obviously I'm still used to Google Cloud style region names where the number is right after the second piece, but indeed it should be US East -2, not US East 2. Okay, so there we go. So you can see it's checking my AWS credentials, and this is the result of that AWS STS get credentials call. So yeah, so that all completed successfully. So at this point, this all should be set up, and I have my default VPC available to me. Now I can move on to actually defining the Terraform bits to actually install Spinnaker. So the first thing here I'm going to do is going to make a directory to store all my Terraform assets. And if we go back to the example script we're working off of here, we had to go to a good amount of work, and nobody likes writing set expressions, at least not that I know, to actually prepare a variables file here and then pass that into Terraform apply. So one of the nice things about the Terraform mixin is it actually makes it a lot simpler to configure these kind of things. So let's go back to our file here, and we're going to add an additional step here to our install. And this is actually going to be Terraform. We do also need to add Terraform to our mixin list here so that it knows to initialize that. One thing I'll note is that you can actually pin this to explicit version of Terraform, but I'm not going to do that today just for simplicity's sake here. So let's take a look at what this configuration is going to look like here. Okay, I think I need to back these up a bit. So you can see here that instead of actually having to configure or do some replacements in preparing a Terraform TFRs file, the mixin just allows you to pass in variables automatically based on the same interpolated values that I had before. Um, it also allows you to define outputs. So in the Terraform itself, there's an output called URL Spinnaker UI, which is assuming everything completes successfully, that actual UI, so you can bounce right to it once it's done. And you can see then we're using identifier, owner, region, team, but we are using one new credential now called SSH key path. And so this is really just an implementation detail of how this Terraform is set up. It's actually, once it provisions that EC2 host out there, it's going to provision my public key out onto that host, and then it's going to use my private key from the local invocation image to actually go out and essentially SSH that host and configure Spinnaker, K3s, all that other good stuff. So that means we do need to add a couple more credentials to our credential list here. And I'll bring that up here in a second. Um, so we do need both the public and private key. Where's credentials? Here we go. Okay. So again, I'm just telling it the path at which I want these credentials to be mounted within the invocation image here, and giving each one a name. And I'll have to regenerate my credentials file in order to bring these in as well. But in the meantime, I'm also going to go ahead and provision my Terraform assets here. So I'm going to have let's see here. I'm going to have two files, a spinnaker.tf file, which is the actual Terraform file, and then a script that Terraform is going to use to actually provision on the host. So I'm going to go into my Terraform dir, touch spinnaker.tf. Okay, and then I'm going to touch install underscore spinnaker .sh. Okay, and that's that. That's my provisioning script. Okay, just in case, I'm going to make sure my install Spinnaker script is executable. Okay. So yeah, so now let's see here. I think we are all set to try actually running this. So the first thing I'm going to do is let's first do a Porter explain so we can see how that's changed. Oops, back up one dir. So again, it's going to rebuild my bundle. I think the extra time is just because it's actually now pulling in the Terraform mixin, but hopefully that doesn't take too long. There we go. Okay, so we can see we now have our credentials, new credentials reflected there as well. So let's go ahead and generate a new credential set. So I'm going to say credentials generate, I'll call this spin 8, something like that. Okay, so I'm going to do the same thing for my STS creds. I'm going to use file path home.aws/credentials. And then I'm also going to use file paths for my private key, which is home.ssh porter, so that's private key, and then file path for my public, which is home ssh porter.pub. Okay, so that's all set. So let's run our install. Again, we have we're gonna change the credentials we're pointing at now. So this was spin 8, and then yeah, I'll just match up my identifier here as well. And this is going to go out and see if we can do this. Okay, so I was able to check my STS credentials again. It's initializing the Terraform backend, installing providers, telling us that it did indeed create a Terraform variable file based off of what we just had in the porter.yaml there. And there it goes. So that usually takes about 10 or 15 minutes. So we're not going to see it actually complete here. And also, this is a sandbox account. So every once in a while, we run out of things like elastic IPs and it kind of blows up. But For 10 or, well, what, 15, maybe 20 minutes of little hacking there and adapting of what we already have, I think this provides a much, much nicer interface for anybody who wants to come along and use this now, because they would essentially just use Porter to pull this bundle down and then do a Porter explain, and then they can understand exactly what it is they have to set up for parameters and credentials, and just go ahead and say install that, and it kind of takes care of the rest. So with that, I'll jump back into my presentation here. So to wrap up, there's a couple other nice things about Porter, additional functionality that I didn't cover in that demo, given the time constraints. So one thing is you can do input and output chain. So each step within any of your recipes there can actually define outputs, and they can also use that same variable interpolation to grab those inputs and pass them into further steps. So you can see here, instead of bundle.parameters, we have bundle.outputs. So that's a nice way that you can actually chain these steps together. The other interesting aspect of this that is kind of not totally finished out in terms of having a stable spec for this yet, but they are looking to support dependencies. And so, especially when you start to consider things like maybe leveraging this in more of an enterprise sort of environment, where you might have, let's say, a DBA team who wants to own like a bundle for deploying a database to a cloud provider, but you want your application to depend on that. You can actually do that today. Today, it only supports direct dependencies. It doesn't support transitive dependencies. So you can't have your application depend on something else that depended on something else. It would essentially only resolve that first step back. But I think they do plan to try to support transitive dependencies in the future. And again, you can have outputs from those dependencies feed into the inputs for your actual application bundle as well. So that's a draft extension, and I think they're looking to get that over the hump sometime soon. And the other thing that's really interesting that I didn't have time to show today, but you can actually also do custom actions in addition to install, upgrade, and uninstall. So, it makes me think of, use cases where maybe your application bundle could also encapsulate things like your runbook tasks for that particular application. Maybe you have some one-off tasks you want to do on your application to actually modify application state. I mean, you can really kind of use this as an extension point to add whatever other kind of actions you want to bundle in there. So I think that's an interesting use case as well. So parting thoughts on this. I think it's a really interesting tool, and I think it's great to see, some real thought leadership in terms of how we can make, cloud native services in general easier to consume, and how we can package those things up and make them, composable and extendable and all that other stuff. So what I showed you today here was actually all running on a pre 1.0 version of Porter, but 1.0 is in alpha right now. And as far as I can tell, it seems like a great community of people, both of users and for developers. They have a forum, they have a Slack channel, and I just think it's a really interesting space. So, encourage anybody who's maybe intrigued by what you saw here today to take a look at the project and think about getting involved with it. And with that, I'll say thank you and ask if there's any questions.
Yeah, and please feel free to come off of mute and ask questions if you like, and I'll give people a minute before I start asking mine, because I do have a couple. Okay, then I'll shoot here quick, and please. There's someone came off mute. Go ahead.
Nobody else has one, I'll ask. Yeah, so you mentioned custom actions at the end there. Is there the capability for like HTTP integration, things like, webhook integrations, things like that? If you wanted to make like a custom action that targets some kind of webhook, I don't know, in like a CI system or anything like that, just kind of spitballing.
Yeah, so I haven't dug super deeply into it, but my understanding is it is really just another action that runs, within your invocation image. So if you can bundle the tool you need for that action into your invocation image, pretty much the sky's the limit.
Sweet.
Cool. Yeah. So, great presentation, by the way. Now, would you equate this as more of the? I mean, so a lot of what I saw is a lot like Helm. Helm obviously specific to Kubernetes. This sort of expands it out to beyond that. And so, am I catching that right?
Yeah, yeah. I think one of the ways that I heard it explained on the podcast by Carolyn Van Slick is, this doesn't really replace any tooling, right? I mean, it really is just a way to sort of glue together your existing tools and put a consistent interface on it. So, Helm is one of the mixins for it. So you could absolutely still use Helm within this, but it's like if you also first want to use like Terraform to go stand up some cloud infrastructure before you use Helm to actually deploy, or even if the other thing is, those the parameterization is so flexible, so you could give somebody a bundle where it's like, a lot of open source software that's meant to run on cloud native today just assumes you have a Kubernetes cluster running somewhere, right? So you could even parameterize these things and say like, well, if you need a cluster, a local cluster, here, just parameterize this and we'll actually install your Kubernetes cluster for you locally too, and then we'll lay in these other pieces and things like that. So yeah, it's really flexible, and especially with the composability of being able to use dependent bundles and things like that, I think it's a space where there's a lot of potential use cases beyond what I showed here today.
Yeah, no, very interesting. And so Porter itself, pretty lightweight. And then
Yeah,
is there any other dependencies? Do you have to have Docker installed already or anything? It's just
so it does require Docker. Yeah,
okay.
yeah, and that is good call out. You need to have Docker, and like I think I mentioned earlier, the CNAB spec itself, it doesn't actually require Docker. It's agnostic as to what your application image and an invocation image is actually bundled as. Porter, being an opinionated framework, uses OCI container images. So you need that, but then Porter itself is it's a Go binary, so it's statically linked. You just drop it on your system and it just works.
Cool. And then as far as like the parameters and credentials, you were passing all those in, but if you didn't pass those in, would it prompt you for those, or does it just give you an error? Or
I think it would actually error out, but I'm not positive on that. Yeah, if you don't pass something in that is required. Um, Now, the other thing I didn't show there is you can also customize like which steps those parameters and credentials are actually applied to. So, for example, let's say I didn't need the SSH keys when I'm destroying the cluster. For example, you can just say these SSH keys only apply to install and upgrade, and then it's actually smart about what it requires when you execute that action.
okay. Yeah, quite awesome. Yeah.
Got a question. Would you be able to set this up to be like cloud agnostic? Like if you were trying to do like like I don't know, would you just pass in a parameter to say, run this script when you're in AWS, run this script when you're in, you know,
Yeah,
the,
yeah, absolutely, and I think that is part of the vision of it. Yeah, you could absolutely write a bundle that was parameterized, and then, let's say you wanted a Postgres database or something, right? And you could pass in AWS, GCP, or Azure, and your bundle could go out and do the right thing for that particular provider.
Hmm.
Now, that's obviously a lot of work, and one of the things I'm yet to see is a ton of, I would say, sort of public Porter bundles, and maybe I'm just not seeing them. But in my mind, it's kind of like building Helm charts. Anybody that's built Helm charts knows the public Helm charts are often way more complicated than like you need as a company. So like they're kind of nice, but like they have to be so configurable and so malleable to like all the use cases out in the public sphere, that oftentimes it makes more sense to just build your own Helm chart, because you can just strip out all the complexity in there, because you probably don't need all those options for yourself. Um, so yeah, obviously, if we're building these things inside of Zendesk, we'd only ever worry about AWS. But if there is more movement to people publishing sort of public bundles, or companies wanting to distribute their software, you could absolutely imagine a world where they say we actually support these three different clouds, and just pass in a parameter to tell us which one you want, and then map the right credentials in for that particular cloud provider, and they'll take care of the rest.
So there is one question in the chat there as well. Can you talk about the history of the project and how it originated?
I'm not sure I can. No, I do know a little bit about that, but I'm a little afraid I may misspeak, and then this will be out on YouTube for all of posterity. But I know it came out of like those companies. I think Microsoft definitely had a lot to do with it. Carolyn Van Slyke, like I said, is one of the main people behind the project, and she's a principal engineer at Microsoft. Yeah, I'm not really sure beyond that, other than there's also, and I'm not sure this actually came out of this, but the Cloud Native Computing Foundation also has a application delivery special interest group. And I know I watched one talk where they talked about how they're kind of in the same spheres. I'm not sure this actually came out of that SIG, but there are, all kinds of, both, within the CNCF special interest groups, as well as, member communities of the CNCF who are getting together and talk about these things. And I believe that's where the idea for the CNAB spec probably came from, is trying to come up with, a vendor and cloud provider agnostic way to provide these kind of capabilities out there. So that's about all I can say about it. I would encourage you for sure to go to cnab.io, I believe, or the CNAB spec itself has its own website. Otherwise, porter.sh has a ton of resources as well, including a link to, I think, a YouTube playlist with all the talks that have ever been given about CNAB and Porter and things like that. So good resources for additional learning.
Okay, great. Yeah, so we're at the top of the hour here. So we thank you much for the presentation. Like I said, excellent. And for everybody else, yes, we'll be skipping next month, but hope to see you back here in February. So everybody have a good holidays.
Thanks all.